Hello, and a massive welcome to all you focused, high-achieving learners out there. I am absolutely thrilled to have you here for today's explainer. Now, listen closely, because today we are fundamentally upgrading how you tackle your Cambridge physics exams. We're stepping into what I call the robot engineer mindset. What does that mean? It means we are going to program your brain for absolute efficiency. We are going to build automated, foolproof patterns for tackling the most common, high-stakes question types you'll face. Whether you're sitting for the 0625, 0651, 0652, 5054, or even gearing up for the 9702, this strategy applies. Today we're using a massive topic, friction fundamentals, as our testing round. Now, to understand why we need this strategy, let's look at a real Cambridge past paper challenge. Imagine a split screen right now. On one side, we have Alex. Alex is the classic overstudier. When faced with a friction question, Alex panics and just overloads the page with raw physics facts, dumping every formula they know onto the paper but providing zero actual analysis. The examiner's red pen just slashes right through it. On the other side, we have Sam. Sam is constantly watching the clock, rushing through the paper, and completely missing the command word requirements. Sam writes friction stops the car and moves on. Again, the red pen shrinks. Both students are losing easy marks. By the end of this session, you won't make Alex's mistake and you won't make Sam's mistake. You're going to have a concept-first, first principles understanding of friction, and a program strategy to extract maximum marks from the examiners.
So let's start where the examiners start. A strong understanding of friction, or any physics concept really, should never ever start with you just blindly writing down a complicated formula. That's what Alex does, and it doesn't work. Instead, it needs to begin with a really simple targeted question. What physical effect, measurement, or prediction actually depends on understanding friction? Posing this starter question grounds the abstract textbook physics right into our messy, everyday reality. It makes the idea feel completely necessary. Think about it. When we realize that friction isn't just some decorative concept floating in a textbook, but an essential physical reality that completely dictates measurements and predictions, we stop relying on perfectly memorized wording. We stop acting like human flashcards, and we actually start thinking like physicists. And more importantly, we start thinking like examiners. Okay, let's dive right into our highly structured syllabus for tackling IGCSE friction today. We'll cover 1. The necessity of friction. 2. The 4-step mastery framework. 3. Cause and effect reasoning. 4. Real-world applications. 5. Avoiding common exam traps. And 6. Quick recall prompts. Section 1. The necessity of friction. Moving beyond memorized wording. To truly master this and to fix the trap that Alex falls into, we absolutely have to start with concrete observations. Jumping straight into formal formulas without context is a massive trap. You have to make the physical idea feel necessary rather than decorative. Think about it this way. Without friction, you literally couldn't even walk to your exam desk. Your shoes would just slip infinitely. When you treat friction as a practical, unavoidable necessity required to walk, to drive a car, or to safely stop a moving object, it completely empowers you. You internalize exactly why friction has to exist in the system you're analyzing. And because of that deep understanding, you can logically deduce your way through totally unfamiliar curveball exam questions based on pure necessity. You won't get thrown off when Cambridge gives you a weird scenario about a block sliding on a ramp on Mars, because the underlying necessity of the physics remains exactly the same. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2. The 4-step mastery framework, a systematic approach to IGCSE physics. All right, let's move to the real strategy reveal. In the chapter on forces and motion, friction acts as a gateway into a much bigger scientific pattern. To master it and to hit every single assessment objective the examiners are grading you on, you must guide yourself through 4 linked steps. I want you to think of this as the PEEL framework, specifically adapted for Cambridge physics. PEEL. Point, evidence, explanation, link. Step 1. Identify the quantity or phenomenon. That's your point. For example, identifying that a car braking involves kinetic friction. Step 2. State the relationship involved. That's your evidence or rule. You state clearly that friction is a force that opposes motion. Step 3. Explain the underlying physics. That's your explanation. You talk about the microscopic surfaces of the tires physically interlocking and gripping the asphalt, converting kinetic energy into thermal energy. And step 4, connect it to an observation or device. That is your link. You link it back to the real observation, the car actually slowing down to a safe stop. This specific automated sequence is your ultimate blueprint. It's how you program your brain to predict physical outcomes accurately and structure an answer that an examiner simply cannot take marks away from. The Cambridge examiners literally say this: the best answers show both understanding and application. This is exactly what they are frantically searching for in top-tier responses. I want to do a quick interactive challenge right now. Mentally put 30 seconds on the clock. If you look at two answers side by side, one where a student just writes friction opposes motion, and another where they go through the 4 steps we just talked about, which one gets the full marks? It's obvious, right? Going through those 4 steps guarantees you aren't just showing you've memorized a textbook definition, which only gets you the understanding marks, but that you can actually deploy that knowledge in a practical scenario, which secures those crucial application marks. It's the Peel framework in action. Section 3. Cause and effect reasoning, moving from everyday language to physics vocabulary. Now we enter the transformation phase. This is where we rewrite Alex and Sam's flawed answers live, and you see those red pen marks transform into beautiful green check marks. This is the absolute core of concept-first teaching. Notice the pacing here for building a remarkably strong answer. You don't just dump all the information at once like Alex did. No, you begin with a concrete example. Then, you introduce a symbolic relationship or definition, but only when you are actually ready to support it. Next, you return to a worked explanation. And finally, and this is a huge one for top grades, if your topic involves graphs, you absolutely must stress what the graph features mean physically. A slope, an area under a curve, a change in direction, these aren't just abstract geometry concepts. They represent actual, physical realities happening in the real world. A decreasing slope on a velocity time graph isn't just a line going down, it physically represents the friction causing a deceleration. When you write your answers this way, you are speaking the examiner's exact language. So the crucial takeaway here is to relentlessly insist on cause and effect, rather than just listing isolated facts. Think about it for a second. Let's do a 60-second mental rewrite right now. Instead of writing, friction is a force, it makes heat, which is Sam's rush style, we use cause and effect. The cause is the rough surfaces rubbing together. The effect is the opposition to motion, which consequently does work and dissipates energy as heat. Boom. Full marks. Whether a topic involves fields, forces, particles, circuits, or waves, you must link them by causality. Friction doesn't just spontaneously happen in a vacuum. A specific force causes a specific, measurable effect. Understanding that chain and writing it down clearly using the blueprint is exactly what separates an average physics student from a genuinely exceptional one. Section 4. Real-world physics applications, where this microtopic matters outside the classroom. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never missed our weekly exam strategy sessions. Welcome to our interactive workshop segment. I'm putting a 60-second timer on the clock for our first challenge, the data scan. Look at the sheer variety of fields on this slide: engineering, safety and transport, energy systems, communications, medical technology, astronomy. Your challenge is to extract the core trend here. Where does friction apply? The answer is literally everywhere. I want to challenge you right now. Always be able to name one real-world situation where your physics concept actually matters. If you get a tough data table about brake pads in a safety and transport context, don't panic. Scan the data, find the friction. From designing incredibly safe car tires with optimal grip to managing the immense destructive heat in heavy industrial machinery, or even calculating the atmospheric friction on a satellite re-entering Earth's orbit in astronomy, ideas stemming from friction appear everywhere, depending on the context. Understanding friction isn't just about passing an exam. It helps us predict or improve outcomes in every sector of human innovation. Physics is quite literally the operating system of the real world. Section 5. Avoiding common exam traps. The safe method versus common weaknesses. All right, challenge 2. Find the flaw. Look at this comparison. It is incredibly tempting to take shortcuts on a test when that exam hall clock is ticking down relentlessly. But relying on weak methods, like writing down a formula without actually explaining what the variables stand for, quoting a physical process without linking it to a measurable effect, or giving a real-world example without showing exactly why it follows the physics rules, is a classic, fatal rote memorization trap. That's what Sam does, and it loses marks every time. Do you see the flaw? It's a lack of connection. Now for challenge 3, speed writing. You have 30 seconds to mentally draft a perfect Peel paragraph. What do you use? You use the bulletproof, safe method. Definition, relationship, explanation, application.
point, evidence, explanation, link. Sticking rigidly to this 4-part structure makes your answers incredibly resilient. Even if you're unsure about the exact wording Cambridge wants, if you follow this framework, you're going to catch the majority of the marks available. It beautifully illustrates the difference between hoping for a good grade and engineering one.
Section 6. Quick recall prompts. Test your mastery aloud.
We're moving into our final system recap. I'm going to give you 3 rules and 4 specific prompts to ensure this topic is completely secure, especially for those tricky, rapid-fire short answer questions. Rule 1, command word decoding. Always know what the question is asking. Rule 2, PL framework application. Rule 3, time management matrix. Now, apply those to prompt number 1. What is the core idea? I want you to test yourself. Can you define the key idea in friction and state one equation, rule, or principle that is clearly linked to it? Say it aloud right now. If you can do this without looking at a textbook, your brain is successfully programmed.
Prompt number 2. What changes physically? When friction is applied in a system, what actually happens to the energy? What happens to the motion? You need to prompt yourself to explain the physics behind friction using that crystal clear, logical cause and effect chain we discussed earlier. Remember, don't just say it slows down. Explain the kinetic energy converting to thermal energy due to the opposing force. That is the level of detail the safe method demands.
Prompt number 3. What quantity your graph shows it? Challenge yourself right now to describe one specific experiment, interpret one velocity time graph, or outline one calculation that is directly connected to friction. And crucially, remember to link the features of the graph, like a decreasing gradient, back to the physical reality of deceleration caused by friction. Listen, students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
And prompt number 4, where is it used? Recall just one real-life example where friction fundamentally matters. Pull from engineering, transport, or even just walking down the street in your shoes. Have that example locked and loaded in your mind. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. I want to end by leaving you with this final, provocative thought. When you think of that real-life example you just came up with, can you justify the link perfectly clearly? Don't just generically say, car tires on a road. I want you to explain exactly why the physics of friction determines whether that specific car crashes or stops safely on a rainy day. Test your reasoning aloud using the 4-step Peel method. By shifting your mindset from stressed-out memorization to calm, automated first principles thinking, you aren't just passing an exam, you are literally decoding the invisible rules that govern our entire universe. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep asking questions and never stop looking for the physics hidden in plain sight.